Hello everyone. In this video lecture, I am going to discuss the cross-disciplinary nature of GIS. In the previous video lecture, I already discussed the concept of GIS, what about the components are there that I discussed. I also discussed the origin of GIS uh, and functions and advantages of GIS. Now in this video lecture, you have to understand that GIS is basically multidisciplinary and multi-paradigmatic field, because lot of interdisciplinary disciplines are attached with GIS. So whenever you learn GIS, then you will face different other disciplines are incorporated with GIS. So all these components that we will try to show you here one by one. So the topic is cross-disciplinary nature of GIS. Lot of disciplinary are interact with GIS so that GIS system run smoothly. So let's start. So first one is there, as you already know, I told you that a lot of people think that GIS is nothing but the computer mapping technology. It is partially true because ultimately the output of GIS is mostly map. So in this case, cartography, this is the another discipline all of you know, where we can prepare map. The ultimate goal of cartography was to prepare and use map. So this cartographic technology also incorporated in GIS in full-fledged way. So cartography is one discipline that is linked with GIS, and all of you understand GIS handle geographical data. So geography is definitely this particular science is also or you may call science or arts or whatever. There's this geography discipline is also directly involved in GIS. Then come GNSS, which is formerly called GPS. Almost all of you have know that in your smartphone nowadays GPS is enabled. So the current terminology we use global navigation satellite system. Let's repeat, global navigation satellite system, which is formerly called GPS, global positioning system. So this is one type of technology by which we can accurately identify the location of Earth's surface with the help of longitude latitude value. So with this particular technology, so this GNSS is one technology that helps you to collect geographical data, and this geographical data then later you can use in GIS. So GNSS technology can be used as a GIS data source. Then come remote sensing. I will explain later what is remote sensing very briefly, but let's just briefly that remote sensing output is also one type of GIS data source. I mean, with the help of remote sensing, whatever the data we collected, this data can be used very effective way in GIS. Then come surveying. Surveying is the another technology, another discipline which is related to GIS, because with the help of surveying technology we can also collect locational data directly or indirectly from space, and this locational data that we can also incorporate in GIS as a data source. Mathematics is a core discipline in GIS. In lot of in GIS especially for vector data structure, for doing different types of data processing, data manipulation, and for doing data analysis. Different types of mathematical technique we use in GIS. So lot of mathematical uh, subjects or topics are apply in GIS. Statistics. You already heard about that geostatistical analysis. In GIS, when you have locational data, this from this locational data we can perform different types of statistical analysis. And by doing statistical analysis, uh, lot of a lot of inner data, lot of inner meaning of the data we can easily extract. Computer science, because you know one component of GIS is computer hardware and software, so directly related to computer. So computer science theory and their practical implementation also have to use also it's a mandatory to use in GIS. As you know, civil engineers or architecture, they also use locational data for construction of bridge, building, dam. So civil engineers, they also handle geographical data for their different purposes, different work. So lot of civil engineer hydrological analysis or many other type of work which civil engineers required, that also incorporated in GIS. And the final one is their photogrammetry. This is another very new digital photogrammetry is a new technology by which directly from the aerial photograph we can collect geographical data. So this photogrammetry technology help you to collect GIS data directly from aerial photograph. So these are the components are there, and one by one, briefly I explain all of these in front of you. So first one is there, you know, that is a cartography. It is the art, science, and technology of making maps. Or in other way, we may say that it is the study and practice of making and using maps. So in cartography, by combining science, aesthetics, uh, and technology, reality can be modeled on a map in such a way that communicates spatial information very effective manner. So combining science, aesthetics, and technology will help you to prepare map, and in such type of map you can very effectively communicate spatial information, or as you know we may call geographical information. Then come geography. It is the science that studies the lands, features, and phenomena of the earth. It is the study of places and relationships between people and their surrounding environments. Geography seeks to understand where things are found, where certain things are found, why they are there. If you want to study why urban landscapes are there and how they develop and how they change over time. So all such type of things basically geographers study, where things are found, why they are there, how they develop, and how they change over time. That basically geographers study throughout their uh, tenure. Then GNSS, Global Navigation Satellite System, formerly I told you called GPS, Global Positioning System. This is nothing, it is a satellite based navigation system which refers to a group of navigational satellites, and those satellites providing signals from space that transmit positioning and timing data to GNSS receivers. That means if you have GNSS receivers, you all of you know that in your smartphone already GPS receivers are there. So these GPS receivers collect such type of positioning and timing data directly from space with the help of those sort of navigational satellites. And then in your smartphone, whatever the GPS receivers are there, then this receiver then use this data to determine its location. So that's a very, very innovative technology. You know that in your smartphone, whenever you on your GPS, then next time wherever you will move with your smartphone, your smartphone will collect your positional information and store it on your smartphone. So this GNSS technology will help you to accurately collect locational information directly from Earth's surface, and this locational data that you can use in your GIS for doing different types of analysis purpose. So this is nothing but a one type of data source. In other way, you can say that GNSS technology is also one type of surveying technology, because with the help of GNSS receiver we can collect geographical data in the form of longitude and longitude and latitude. Then remote sensing. It is the acquisition of information about an object or areas without making physical contact with the object, without making any contact to the building or tree. If you can easily collect their information from far away, that is called remote sensing. So it is the science of obtaining information about objects or areas from a distance, typically from aircraft or satellites. If you collect information from aircraft, and this output is called aerial photograph. If you collect this information directly from satellite, then this is called satellite image. So whatever is there, whether aerial photograph or satellite image, they represent certain area of the Earth's surface, and whatever the geographical features are present in this particular Earth surface, that they store as a image or raster data. So this is also a very, very useful source for GIS. So this is a GIS data source. Once you collect such type of aerial photograph or satellite image, different types of GIS analysis you can perform. And from this satellite image, from this aerial photograph, you can extract a lot of additional information. Okay, so remote sensors collect data by detecting the energy that is reflected from the Earth's surface. And the source of energy is mainly use solar energy. And when this solar energy reflected from the any object that are present on the Earth's surface, So this reflected energy collected by the sensor either on board aircraft or on board satellites. So this is a very useful data source. Then come surveying. It is the technique of determining the position of points and the distance and angles between them. So survey data is a very useful GIS data source. With the help of theodolites, total station, many other survey instruments are there. You just use it and go to the ground, and directly from the ground you can collect locational data. And this locational data, this survey data, later you can use in GIS software, and you can perform different types of data analysis. So it is the technique of determining the relative position of different features on, above, or beneath the surface of the earth by means of direct or maybe indirect measurement, and finally representing them on a sheet of a paper as a map, or sometimes called as a plan. Okay, then come mathematics. It is the study of quantity, space, structure and change. So lot of mathematical topic or mathematical theory we use in GIS. For example, if you use we use predicate logic in spatial database, different types of Boolean operators like and, or, not, which are very common types of logical operators we use in GIS data. And by using these Boolean operators, all logical operators, different types of very sophisticated GIS analysis we can perform. We frequently use set theory of mathematics. We use derivatives in different types of geographical data. We also use graph theory, topology. So all are basically the core theoretical concepts regarding mathematics. Set theory, graph theory, derivatives, topology. So that are interrelated in different types of GIS, GIS process, GIS analytical tools. Next one is there, which is called statistics. So statistical analysis basically helps you to extract additional information from your existing GIS data. So in your existing GIS data that might not obvious simply looking at a map, some sort of information that are not readily visible in your GIS data. But by doing statistical information, we can extract these additional meanings from your existing GIS data. Information such as how attribute values are distributed in your GIS data. Suppose how the crime pattern distributed in a city. Whether the crime patterns are whatever the patterns of your crime data, whether they are dispersed or clustered. So that is very easily we can find out. Or in a simple way, if you want to find out mean, average, standard deviation, variance, such type of vital information, that is possible. Whether in your data in a normally distributed or not. So those sort of things, whether your data have any trends or not, whether your data is biased or not. So that are sometimes not readily visible in your existing GIS data. Suppose if you have a population data for your city or your state, if you have uh, crime data for your city or state, if you have socio-economical data in your state, where such type of hidden informations are there which are not readily visible. So by doing different types of statistical analysis, we can extract such type of things from your existing GIS data. So for doing this, lot of statistical theory concept you have to understand, you have to learn, because GIS borrow all such type of statistical theory in it. And then come, as you know, the computer science. It is the study of the computational theory and their practical implementation in computer system. You can't implement GIS if you do not use any computer, and once you use computer you have to know the computation theory, how they store data, how they handle data, how they handle binary data, and their practical implementation. Lot of computation theory like machine learning and the numerical operations. So all such type of things, it's a common computational theory that you have to know in when you use GIS in your computer. And then come civil engineers or any other engineering discipline who are using locational data. For them, they also have to use GIS. So it is the field of engineering that deals with the fixed structure like building, bridge, dam, etc., which are related to the earth. Civil engineers, they need to perform hydrological analysis for construction of dam, for find out the suitable location for a new dam setup. So this lot of civil engineering core concepts also incorporated in GIS. And the final one is there, which is called photogrammetry. It is the practice of making accurate measurements from images or from aerial photographs. Photographs that was captured from the aerial platform. So from such type of aerial photographs, if you want to extract geographical data, supposed to be, I'm just giving you one example. From the aerial photograph, if you want to extract the building height, tree height, road elevation, so that are possible with the help of photogrammetry technology. So in GIS software nowadays, this photogrammetry technology is also incorporated, so that once you collect building height, tree height, or the surface elevation point, that can be used in GIS for doing different types of map making and map analysis purpose. So these are the main discipline or technology that are directly related with GIS, and I just try to present you some of these main disciplines or interdisciplines or technology that are related to GIS. So thank you.